This video is to go over homework packet 2B, lesson 2.06. And problem number 3, segment BE bisects segment AD at C. That tells us that segment AC is congruent to segment CD. And it says choose the correct reason for step 4 in the following proof. It says segment B bisects segment AD at C, so point C is the midpoint of BE. And that is given. So that tells us that segment BC is congruent to segment CE. And the second sentence said segment AC is congruent to segment DC because definition of bisects. So segment DC, this actually bisects this segment AD, therefore the lengths between length AC and length CD is exactly the same. And also segment BC is congruent to segment EC because of definition of midpoints. And also it says angle BCA, which is right there, this angle, is congruent to segment ECD. Why? So that's the question. Would that be straight? So you got the 4 multiple choice. It says straight angles are congruent, or corresponding angles are congruent, or opposite angles are congruent, or vertical angles are congruent. So these are. So you choose one of this. Be careful with the word opposite and vertical. That's the hint. Problem number 4 says we have such shape as this, and we get the 1 tick mark right there, and also we got another mark right there, and we say A, B, C, D. And this is very similar to problem 3, but you're going to have more statements. So it says provide the missing reasons in the proof to show that segment AC is congruent to segment DC. Why segment AC is congruent to segment CD, right? So A first says segment AB is congruent to segment BD because it's given. And also segment ABC, which is this angle right there, and also DBC, measurements angle DBC, is congruent because of this tick mark. So that's going to be, the reason will be given because it's given. The given means it's on the problem. So the problem says use the figure below, segment AB is congruent to segment DB, and measurement angle ABC equals measurement angle DBC. Therefore, this is given. So why segment BC is congruent to segment BC? Well, because it's, and therefore triangle ABC and triangle CBD are congruent because of one of those, the triangle congruence theorem, one of those triplets. So you're going to write one of those. And at the end, so this triangle ABC is congruent to triangle DBC, then corresponding parts of corresponding triangles are congruent, so you write that as a reason. Problem 5. In this figure, PQRL says, and we got the line there, so PQRL, and it says segment PL is congruent to segment RQ, and segment PQ is congruent to segment RL. Prove each of the following below. Triangle QPL is congruent to triangle LRQ. Why this is equal? So now you're gonna have to have so step 1, step 2, whatever, and then at the end you're gonna have to say triangle QPR is congruent to triangle LRQ because of You know, for example, SSS or SAS or ASA or AS. You know, one of those triplet. So in order to say those are actually congruent, you're going to have to show that those angles are, I mean, that side is congruent to this side because, you know, that kind of thing. So I'll give you one hint. So one other thing is, okay, segment QL is congruent to segment QL, you know, because it's sharing the same exact. We were talking about the same thing. So we've got that. What else do we have? So I'll give you another one. So in the problem it says PL is congruent to RQ, right? So we've got the two S's. So maybe we can either do SSS or SAS. We don't use ASA because we already have two angles. So it's the reason that those two triangles are congruent is either SSS or SAS. Problem number 6, use the figure below. So we have something like this. That's problem 6. We have A, B, C, D, E, F. It says measurement angle DBC equals measurement angle ECA. So we should put the tick mark for that so that we can keep track. So segment measurement DBCB, so that's this guy. And then we have segment ECA. We don't know how many degrees are they, but we know that those two angles are congruent. Point ECD are collinear. So ECD are collinear. That means this is, you know, this part is collinear. Okay? And also it says segment FC is perpendicular to segment ED. So right there, that's 90 degrees and here's 90 degrees. Hey, based on the given information, what can you prove? What can you prove? What can you say about the other angles? We have 4 angles. And what can you say about, we know that two angles, a pair of angles, BCD and ACE, which is these guys are congruent. What can we say about this angle and this angle, for example? And once you get that conjecture, then prove your conjecture for part A. And that's 2.7.